Hello viewers, welcome to Quick Mathematics. The problem is solve using matrix inverse method, the system of linear equation 3s plus y equal to 32, s plus y equal to 14. So you can also solve a pair of simultaneous linear equation using matrix inverse approach. So let's take the quick solution. To continue, we have to label the two equations as equation 1, that is 3s plus y equal to 32, then s plus 3y equal to 14 as equation 2. Because we are using the matrix approach, we have to define about three matrices. The first one is coefficient matrix. Let that matrix be A. You obtain that matrix by considering the s column and the y column in the two equations. In the two equations, this is the s column, so the coefficient of s in equation 1 is 3 and equation 2 is 1. For the y column, the coefficient of y in equation 1 is 1 and equation 2 is 3. The next matrix is the variable matrix denoted by s. The variable you want to solve for, variable s and y in column form. The third matrix is the constant matrix denoted by b. That is the right hand side of the equation, 32 and 14, also in column view. We have to put all these matrices in matrix form. So the system in matrix is the coefficient matrix multiplied by the variable matrix equal to the constant matrix. If we are to use the inverse method, remember we are looking for this matrix, and the solution is matrix S equal to inverse of matrix A times B. So A to the power of minus 1 is the inverse of the coefficient matrix. Okay, so first we have to get the inverse, and the inverse is 1 over determinant. So this is the determinant of 2 by 2 matrix is the difference of the product of the two diagonals. That is 3 times 3 minus 1 times 1. That is what you have here. For the inverse, the position of this element, they are interchanged usually, but since they are the same, you have 3 3 there, and the other diagonal 1 and 1, you negate it, meaning you multiply the second diagonal by minus 1. So the entries in that place, 1 and 1, becomes minus 1 minus 1. So you have 1 over 8. When you simplify the denominator, that is 9 minus 1, it's 1 over 8. Then this matrix remains the same. So that is the inverse. So we go to the solution. So in the solution, that is matrix S, we multiply the inverse by the constant matrix. That is what you have there. So when multiplying, you take the first row, 3 minus 1, to multiply the first column or the only column. When you are done, you take the second row minus 1 3 to multiply the only column as well, and that is why you have it 3 times 32 plus minus 1 times 14. That is the first row times the only column. The second row times the only column. You have minus 1 times 32 plus 3 times 14. So 1 over 8 is still there as a constant or a scalar. So you have 3 times 32 is 96, plus minus is minus, 1 times 14 is 14, minus 1 times 32 is minus 32. Then you have plus 3 times 14 is 42. So here 96 minus 14, you have 82, minus 32 plus 42, you have 10. So this matrix S, the entries are small s and y, so equal to 1 over 8 into 82 and 10. So by scalar multiplication, the value of s is equal to 1 over 8 multiply 82, that is 82 over 8. If you reduce, you have 41 over 4. To decimal, you have 10.25. The value of y is equal to the same 1 over 8 multiplied by 10, that is 10 over 8. If you reduce, you have 5 over 4. To decimal, 1.25. So this is how we use the matrix inverse method to solve system of simultaneous equation. For updates, for more quick mathematics, follow the voice of Peter Course via YouTube at Peter Course Simplified Maths. To do that, subscribe to this channel, like this video, share it to your friends, your colleagues, your classmates, your students. You can also follow Voice of Peter Course via Facebook, Instagram at Peter Course Simplified Maths. For questions and inquiries, use the comment section and we attend to them. Goodbye.